Well, hi there, kiddos. Hope that you have had a very good week. Today we're going to talk about functions and relations. You should have a blue foldable that is already folded and cut for you that has the letters NAGS on the front. I want you to flip it to the back side of that. There are some definitions. That's where we're going to start. And then we'll come back to the front part, the flappy part, in just a minute. So we're going to start on the back. The first thing you should see is a relation is and a function is. So the first thing we have to do is we're going to have to do some definitions. We're going to have to learn what a relation is and what a function is. A relation is nothing more than a set of ordered pairs. A function is a relation where every x is paired with only one y. We're going to say the words exactly, with exactly one y. What this means to you, in parentheses I want you to put with a big star, because this is the important part. What this means to you is that a function is a relation where no x values repeat. If x values repeat, then you cannot have a function, and we're going to talk about that in just a little while, but that's the important part. X values cannot repeat. A function is a relation where x values do not repeat. So we're going to use that information to determine if I've got some relations that are a function. So the first thing we're going to do, we're going to determine if these are a function, and then we're going to write the domain and the range, whether they're functions or not. So we're going to look at the first one, number 1. We're going to only look at the x values. So you can underline them, highlight them, circle them, whatever it is you need to do. I'm going to underline. We're just going to underline the x values in an ordered pair. Remember, x is always the first number, y is the second number. And in this relation I have right here, I have 1, 2, 3, 4 different ordered pairs. So I should have 4 different x values. So I have 0, 1, 0, 2. And if you will notice, this 0 and this 0, I have an x value that repeats because the number 0 showed up in the x place more than once. So this is not a function. We still can, however, list out the domain and range of this. And so the domain, we're just going to list out all the x values, remember, in order from least to greatest, and we don't list things that repeat. So the smallest one is a 0. It shows up twice. We only write it once. Then a 1. And a 2. So there's your domain. Now for the range, we'll list out all our y values in order from least to greatest. So it looks like they go 1, 2, 3, 4. 1, 2, 3, 4. The reason our range is longer than our domain is because there was a repeated number in our domain, and so we didn't write it down. So now number 2. We're going to do the same thing. We're going to go look at all our x values, see if any of them repeat. So we're going to underline them, highlight them, circle them, whatever you need to do. So I have a 2, a 3, a 4, a 5, and a 6. Every single x value I just underlined and said out loud is a different value of x. None of them ever repeat. So this is a function because none of the x values repeat. So then when I write my domain, in order from least to greatest, I have 2, 3, 4, 5, and 6. My range is my y values, and I got to put them in order from least to greatest. It looks like the smallest one is -2, and then the next one is a 1, and then I have a 3, and I have 2 of them. I've got this 3 and this 3. I'm only going to write it one time, and then I have a 5. So in this case, my range was shorter than my domain because I had repeated values in the range. That's okay. You can still have a function if your range is shorter than your domain. You cannot have a function, however, if your domain is shorter than your range. Because if you have fewer numbers listed in your domain than you do in your range, when you're writing out from a relation, it automatically tells you you had repeated values. So now we're going to talk about this thing called the vertical line test. Okay? So the vertical line test is just a test we use to see if the picture or a graph of a relation is actually going to be a function. And so the vertical line test says that to be a function, let me start this sentence over. In order for a graph to be the graph of a function, So in order for a graph to be a function, it has to pass the vertical line test. And the vertical line test says that a vertical line will not pass through the graph of a relation in more than 1 point at a time. And I'm sure that that does not make a whole lot of sense to you right now. It'll make a whole lot more sense after we do it. So we're going to do some practice. But basically it says that a vertical line, which looks like this, it goes straight up and down. Okay, a vertical line cannot pass through the graph of a relation in more than 1 point at a time, because what it is saying is that x values can't repeat. If x values repeat, they line up vertically on a graph, because that's how they work. The x value stays the same, but the y values, the up and down part, changes, so it makes it go up and down. And so you can never have 2 points that line up and down from one another and still have a function. So we're going to test to see if some graphs are graphs of functions. So we're going to use the vertical line test to determine whether each of these relations is a function. If a relation is not a function, we're going to write out two ordered pairs that show the same x value with two different y values. So the first thing I'm going to do is I'm going to pull up a line that we can use. There's my vertical line. It goes straight up and down. You can use a pencil. You can use the edge of a sheet of paper. Anything that you can lay onto your graph that goes vertical and goes straight up and down, and then you can do what I'm doing. I'm just going to use my line. It's a little easier to see. A pencil, pen, all of those work perfectly. But if I take my vertical line and I put it over here on the left end of this graph, the vertical line test says if I take this vertical line and I move it across this graph from the left to the right or the right to the left, but I move it across this graph, if there is ever a place where this vertical line crosses this graph, the line that is drawn, not the coordinate plane itself, the line that is drawn in more than 1 point, then what I have is not a function. And if you will see, I have my vertical line right here, right now, and that vertical line hits this graph here and here. And so if I move my graph over, or my line over so that you can see, it hit it in two places at once. It will happen in several other places here. It also hits it here and here. If I were to put my vertical line right there, I've got 2 points that line up. Same thing happens over here. In multiple places, I have 2 points that line up vertically from each other, which means I do not have a function. So I get to say this is not a function. And it's not. If something makes a circle, it cannot be considered a function. Not the kind of functions we study in Algebra 1 anyway. So now that I know it's not a function, I've got to write out two ordered pairs that show the same x value with two different y values. So I got to show the x values repeat. So I'm going to use these two that are right here in the middle. This one right here is going to be 0, 7. And this one down here is 0, -7. And so what you should see is that I have x values that repeat. Just like I told you a minute ago, x values cannot repeat and you have a function. It just can't. So now we're going to take our vertical line. We're going to go over here to number 4 and we're going to do the same thing. I'm going to move it across this V shape that is drawn on here. And hopefully you will see, excuse me, that this vertical line never passes through that V in more than 1 point. Right here, it passes through it in 1 point. If I move it over here, it's still passing through it at 1 point. There's never a place where there's 2 points lined up on this vertical line at the same time. So this one is a function because it passes the vertical line test. And since it's a function, I don't have to go do the special thing where I write two of the ordered pairs. It's just as a function, it passed the vertical line test. So let's take our vertical line. Let's go down here to number 5. And you see number 5 is not connected points. This is actually a little bit easier. I'm just going to see if any of these points line up vertically on my pretty little line here. So I'm going to lay it down. Oh, look. Those 2 points are both on my vertical line. Automatically not a function. But if you see, so do these 2 points and these 2 points. So I have 3 different places to pick from, but this one is not a function because I have more than 1 point that line up. And so I'm going to have to pick 2 of them and write them down. So let's do the 2 that my line are going through right now. So this top one up here is going to be 3, 1. And this one down here is 3, -1. So you should see x values are repeating. Now the next one's kind of tricky because if I take my vertical line and I put it on my graph, they are now the same thing. There is a reason we use a vertical line to test to see if something's a function, because a vertical line itself is not a function. If you want to know if something is something, you use its opposite. Okay? So, if I want to know if something's a function, I use something that's not a function to compare it to. If I want to know if my dog is really a dog, I'll put her up next to a cat and see if they have anything in common. Other than the fact that they have 4 legs and fur, they don't. Okay? If I want to know if my taco is really a taco, I put it next to a burrito. They're not the same thing. One of them has a, crunchy shell on the outside, and you can see the insides really well. The burrito's all rolled up. Everything's all closed inside. So if I want to know if something's a function, I use something that's not a function. So this one is automatically not, because my vertical line touches that all over the place. Anytime you see a vertical line, you should automatically be like, oh, that's not a function, because it touches, the x values repeat everywhere. I have 2 points that line up. They line up vertically. This one right here is going to be at 7, 4. And this one down here is going to be at 7, 1. So you see repeating x values cannot be a function. So now flip to the front of your foldable. We're going to go to the front. This is where we are. And we're going to flip open our flaps and we're going to write down some stuff. So there are 4 different ways that we can represent a function. The first way is numerically. So we're going to take our N tab, and you're going to write the word numerically on the front of it where the N is. And then we're going to open it up. When we open it up, this should be what you see. So inside, we have ordered pairs. And so the first thing that we're going to do is we're going to use those ordered pairs, and we're going to list out our domain and our range for these ordered pairs, and then we're going to decide, based on that, is it a function or not. So we can list it as a set of ordered pairs. It's just a relation, but let's do our domain and range. So the domain from this relation, remember, it has to go in order. Looks like 2, 3, 4, 5, 6. They go in order. 2, 3, 4, 5, and 6. And then we're going to write our range. This is going to be helpful in a few minutes because we're going to need it. And we're going to write our range in order from least to greatest. So I'm going to do the -2, then the 1, and then the 3. And it repeats, so you only write it once, and then the 5. Yes, this is the one that we did on the back side. We've already done this one. So now we're going to take this domain in our x's and our y's, and we're going to put them in a table. So we're going to go from the ordered pairs to the table. So this is x, this is y, and I'm just going to take each ordered pair and put it in the table. So the first ordered pair is 2, 5, so I go 2, 5. The next one is 3, -2, then 4, 3, 5, 1, and 6, 3. All I did was convert these ordered pairs to points on the table. Same thing. So I'm going to give you a second. I want you to try B. Let's find the domain and the range first. Then go fill in your table X and Y. So it looks like our domain is going to be 0, and there's 2 of them. They repeat. We'll only write it once. 2, 3, and 4. And then our range, we're going to list out our range. So we're going to start with -1 is the smallest. Then we have a 0, and then a 1, a 2, and a 4. And so I've listed out my domain and my range. We're going to use that later, but I'm going to put my ordered pairs in the table. So I have 0, -1 is the first one, then 0, +1, 2, 2, 3, 4, 4, 0. So that's numerically. You can either see it as a set of ordered pairs, you can see it as a table, but that's how we write them numerically. The second one is going to be algebraically. So close that flap, go to your A flap, and underneath the letter A, I want you to write algebraically, because algebraically is another way that we could see functions represented. So here we go. We're going to fill in this flap. So by algebraically, what I mean is we could write them as equations. And so the first equation looks like this. We have 3/4 x minus 5 equals y. Well, that equation is an equation that we would see. We're going to talk about the different parts of it in a few days. But because this is written as y equals, and then we have a 3/4 x plus 5, we should automatically know this is a function. We're not going to write that it's domain and range or anything, but we are going to put what the independent and dependent variables are, because we're going to go back to what we did a few days ago. So we have our independent and dependent variables. And remember, when something is written as an equation, the variable all by itself is always going to be your dependent variable, and the variable that's over here with all the other stuff will be independent. So in this problem, y is dependent, x is independent. Now the next one, I have v equals 4/3 pi r cubed. And so it looks like I have 3 variables, but I really don't, because you should all know that pi has a value that we use. It's 3.14. Pi is just a symbol to represent that value because it is a number that goes on forever and ever and ever and never repeats itself. So we just use pi, and then we simplify it, shorten it to 3.14 when we use it. So this is not a variable, it's just a symbol. So I have 2 variables, v and r cubed. This right here is the equation for the volume of a sphere. We can still identify our independent and dependent variables, just like with this one. The variable all by itself, the v, which stands for volume, is going to be dependent, because in order to be able to find the volume of a sphere, I have to know the independent, which is r, which stands for radius. So there's my independent, dependent variables. That's how we represent functions algebraically. We just use an equation. So now go down to the bottom left corner, to the one that has a G on it, and I want you to write the word graphically on there, because we can also represent functions and relations graphically. And there's a couple ways to do that. So write the word graphically, and then I want you to open your flap. 2 ways to do this graphically is to take our ordered pairs and just plot them on a graph. So like on the left-hand side where it says coordinate plane. The first way we can do that is just to plot our points. So I'm going to go back up here to A. And I'm going to take these points that we listed for A, and I'm going to plot them on my coordinate plane. So I'm going to scroll down just a little so I can have it all on the page. We're just going to plot these points that we put in our table, or you can plot them straight from the ordered pair relation. I'm going to use the table. So the first one is 2, 5, which means I have to go over 2 and up 1, 2, 3, 4, 5. Then the next one is 3, negative 2. So I'm going to go over to the right 3 and then down 2. Then 4, 3, and then 5, 1, and then 6, 3. And we are not going to connect them because this is going to be a discrete graph. The data is not connected, so we're just going to leave it all unconnected like that so that you can see what it looks like. Now the mapping is something you haven't seen before, but they are very, very simple, especially if you have already found the domain and range for the relation you're wanting to deal with, which we did already, and I did that on purpose because it makes the mapping easy. Mapping is just what it sounds like. We're going to draw a map that shows which x values match up with which y values. Here's how it works. You always have 2 ovals. The first oval is your x values, the second oval is your y values. And we just list our domain and our range here, because just like with domain and range in a mapping, you do not list numbers that repeat, and you always write them in order from least to greatest. So for this first one, my domain is 2, 3, 4, 5, 6. It was what goes over here, 2, 3, 4, 5, 6. That's why it's helpful to do domain and range first, because then you just plug them in. They have to be in order from least to greatest in a mapping, and you do not list values that repeat. And so my range is the numbers negative 2, 1, 3, and 5. And now all I'm going to do is I'm going to take arrows and draw arrows from the x's to the y's that they match up with. So you will see that the 2 matches up with the 5. So I'm going to draw an arrow that shows that this 2 goes with that 5. Then the 3 goes with the negative 2. So I'm going to show my 3 goes with the negative 2. The 4 goes with the 3. The 5 goes with the 1, and the 6 goes with the 3. So I have 2 arrows going to the same place, which is totally fine because that means a y value repeated and it's all okay. Only time it's not okay, I mean it will still happen, but the only time that it's not okay is when we have 2 arrows leaving from the same place, which is getting ready to happen in the next example, because that means we don't have a function, because that means x value is repeated. So let's do the next one. Let's do B. We're going to put it on the graph. So we're going to plot these points. So I have 0, negative 1, and I have 0, positive 1. And so you will see I have 2 points that line up vertically. So if I were to do my vertical line test, it would not pass it. Then I have 2, 2, 3, 4, and 4, 0. We're again not going to connect the dots. It's a discrete graph. But then we're going to take our domain and our range and we're going to make our mapping. So we have x and y. So we're going to do our domain was 0, 2, 3, 4. And our range was -1, 0, 1, 2, and 4. And we're going to draw our arrows. So 0 went with -1, and 0 also goes with +1. So you see I have arrows leaving from the same place, which means I don't have a function because it made them line up like this. Then I have 2 goes with the 2, 3 goes with the 4, and then 4 goes over here with the 0. So just draw my arrows, make a match. So the last way that we can represent a relation or a function, wrong button, I apologize. The last way that we can do that is to use a sentence. We can do it in a sentence or do it verbally. So under your S, I want you to write the word sentence and in parentheses put verbally, because to write something in a sentence is to do it verbally. You're not saying it out loud, but you are writing it, so it does put it in words. And so here's how it works. So we have 2 word problems, and we're going to go from the words to an equation so you can see that they all sort of go together. So I have that 2 candy bars cost $1, 3 candy bars cost $1.50, and 4 candy bars cost $2. So in this case, we're not really going to write an equation, but we can convert this to a table. We can have the number of candy bars and how much they cost is going to go in our table. And I know that 2 candy bars is $1 because that's what the first sentence said. Then it says 3 candy bars is $1.50. And then 4 candy bars is $2. And if I wanted to go from there, I could make a graph, I could make a mapping, I could write my domain and my range. I could determine if it was a function or not, just based on what I have. But that's how we write it verbally. So number 2 says that a math club buys t-shirts for its members. A clothing company quoted the following prices. 10 shirts are $75, 15 shirts are $105, and 20 shirts cost $135. Again, number of shirts and money, we can make a table. 10 shirts is $75. 15 shirts is $105, and then 20 shirts is $135. And just like with the one before, we now have it in a table. We could write it as a list of ordered pairs. We could graph it. We could map it. We can look and see if it's a function or not. We can even talk about what's independent and dependent. So the 4 ways to write it. You can write them numerically with either as ordered pairs or a table. You can do it graphically through a coordinate plane or mapping. You can do it algebraically by writing an equation, or you can do it in a sentence verbally by writing out the words. So that is functions and relations. The things that I really want you to think about is that to be a function, no x values can repeat, which means that it also has to pass the vertical line test where you draw your vertical line across your graph. Use a pencil or an edge of your sheet of paper. Y'all will practice this weekend, and I will see you on Monday.